Project name, improving the quality, and updating of SecGIS Western Sector. GIS Conversion Guide, 28 Oct 2023. Contents: Survey Data Excel Kuakuchi Checklist. 3. Survey Data Cleaning, Domain Assign. 5. MXD Preparation. 6. Conversion of survey data into GDB. 8. Loading GDB to EUDM. 10. Adding data to ArcMap, activating hyperlink.12. Templates, placement. 13. Connectivity of ED service points. 17. Overhead network digitization. 20. Underground network digitization. 22. Survey Data Excel Kuakuchi Checklist. Survey team will deliver one folder of survey data that contains pictures, Excel, sheet. Open survey data Excel sheet and make a visual check for the primary fields X, Y, number, hyperlink in all assets. Open data entry QCQA, checklist, .xlss, and fill highlighted information's file, Name, QC engineer Name, duration, etc. Go through all the checks carefully, fill status and defects accordingly. Open next sheet of QA/QC checklist for all the assets and fill all errors with respect to the remarks field. While updating QA/QC checklist, open survey data Excel sheet and fix data entry. Errors. Please refer to mandatory list, SEC, Westscope, VON documents. Note: if there are major errors, take screenshots and file a report. Survey data cleaning, domain assign. Create a backup from survey data entry validated Excel sheet. Open GIS domains Excel sheet and fill coded values on your final survey data Excel sheet. In this case, poll material still equals 1. Convert all fields provided by survey team into coded values as shown previously. MXD preparation. Open new ArcMap blank page, right-click on Layers, Properties. On Coordinate System, choose Projected Coordinate System WGS 1984 Zone 37. Click on File, Map Document Properties, Copy Pictures Path, paste it on Hyperlink Base. Click OK, save MXD. Conversion of survey data into GDB. Add survey data Excel sheet by click on Add Data icon, select Cleaned Survey Data. Excel sheet, add all. Right-click on Added Data, display XY data, repeat for all assets. Make sure all informations are valid. Right-click on Displayed Event, Data, Export Data. Create new file geodatabase, name it, name feature class, remove the event. Loading GDB to EUDM. Open ARC catalog. Take a copy of EUDM GDB schema and name it Zone X. Right, click on Zone X. GDB, click the target feature class you want to load, load data. On Simple Data Loader, next, input data, click on Source Feature class. Click on Add, next, make sure target source fields are matching. No error message should display if all values are coded exactly from Domain Excel. It's crucial to verify all attributes are loaded 100% correctly. Adding data to ArcMap, activating hyperlink. After all electric assets are loaded successfully, we will activate hyperlink for all assets. Right-click on Feature, Properties, Display, Hyperlinks, choose Hyperlink field. Follow same steps for all electric assets feature classes. Templates, placement. SEC provided a template for stations, substations, RMU, distribution box. Load UDM, favorites into Zone X, follow same steps on page 10, 11. Once you added data, right-click on any internal templates component, zoom to Layer. Click on Bookmarks, Create Bookmark. Click on Customize, Customize Mode, Commands, search for Mirror, drag, Mirror tool, and drop it the toolbar. Start Edit, select the database you want to edit on, click OK. Using Hyperlink tool, click on Asset and check Photograph. Sample 1, Pole Mounted. Copy, mirror the template asset according to features subtype and photograph. Select Template, Mirror, right-click on any vertical line, parallel. Select Mirror Template, drag and drop on substation point, press to go back. To previous extent, rotate template towards street. Sample 2. Unit Substation. A substation in reality must be converted in the same set of equipment in GIS with components such as transformer, switchgear, LVDB. Even the mentioned switchgear and LVDB areas will have their own internal components such as fuse, switch, plant, schema, cable, and others. Apart from digitizing the underground network data internal template, we will update all remaining attributes, maintain connectivity as per data model's geometry, network rules, and data validations, etc. We will do our level best to completely documenting electrical distribution network per approved specification. Note, refer to mandatory lists, SEC, Westscope, VON, doc for types of substation. Templates. Connectivity of ED service points. In the GIS project, we are representing the service point location for meters as EDSP, FCL, E to service point. So we will represent each meter box as a service point, and the meters available in a meter box will be related to that particular point. Through the relationship feature class, all meter details will be stored as table OCL, meter, and the existing relationship feature class will look up the values of relations between the meters and the service points. ERI will place a point for each meter box available as per the field survey data. If the adjacent meter boxes are fed by same SOS through interconnected cable between both the meter boxes will be looped when there is a clear evidence from the photographs. Rules to be followed. One ED service point will be captured for each meter box. Service connection cables will be drawn as per as-built maps for underground connections. Service connection will be captured as per photographs for overhead connections. Looping between adjacent ED service points will be done with respect to photographs. Do not loop when there is no clear evidence in the photographs. Single EDSP for single meter box. Single EDSP for double meter box. Single EDSP for quadruple meter box. Single EDSP for many meters. Multiple EDS at same location as per number of meter boxes available. Overhead network digitization. Overhead network includes the infrastructure and electrical assets constructed above ground, and the main electrical conductors are connected between the poles, and all other electrical equipment also be installed in the poles. As per our GIS project requirements, we need digitalize the entire distribution network, which includes both MV and LV network. Overhead digitalization rules. Overhead conductors are represented as single line for each feeder circuit, consist of 4 lines, 1 feeder line. These overhead conductors are digitized by connecting the surveyed poles X, Y location which available in the database. Single feeder running in the route will be captured as single line, and wherever the joints are required will be placed accordingly. When there are 2 or more than 2 feeder circuits running in the same route, then the network lines will be captured with the offset gap of 0.2 meter between each other conductor. If MV and LV conductors passing through the same pole, then MV line needs to be drawn over the poles and LV need to offset 0.2 meter from the MV line. LV lines always be done with offset towards the parcel boundary to avoid unnecessary overlap of LV, service cables, network cables with MV network. Overhead cables crossing each other is allowed between MV and LV all over the data, but there should not be any physical vertex added between the networks. Overhead network lines should have the joints, any OH equipment at both the ends. Overhead network joints are placed according to the connectivity and branches, made from the particular pole location. OH lines should not be split at the poles except following 2 conditions. When any attribute change occurs in the OH line, when any OH line equipment placed over the pole, when OH joints are available in the network.
Underground network digitization. Underground network includes the electrical cables buried under the ground, along with connected electrical assets constructed above ground. The main underground cables are connected between the electrical equipment such as substation, distribution boxes, and meter boxes, etc. As per our GIS project requirements, we need digitalize the entire distribution network, which includes both MV and LV underground network, which is based on the company provided inputs such as built, CAD drawings, SLD, and hard copy maps. Underground cables are digitized by taking offset from SEC provided base map. Layer parcel row edge. The major rule is that offset between UG cables are always 0.25 meter. Between LV cables, 0.25 meter. Between MV cables, 0.25 meter. Between MV and LV cables, 0.25 meter. UG cables drawn from on-site of the Tracy parcels should not cross the street. Centerline. Always as priority, MV network cables should be digitalized first, and the LV network cables can be drawn next. The major factor decides the first UG cable drawn from parcel edge is based on the street row width. We need to measure the distance between the opposite sides of the parcels as row width by using the measure tool in ArcGIS, and then we can decide the first MV and LV line offset from the parcels. See below are the different conditions for applying offset for UG cables. Case 1. Street row width is more than 10 meters. MFI underground cables. If the street width is more than 10 meter, first MV cable should be digitized at 5 meter distance from parcel boundary. Additional MV cables needs to be digitized by maintaining 0.25 offset from first MV cable towards the street center line. When your offset is about to cross the street center line, then your MV line can be drawn 0.25 meter offset towards the parcel line from the first MV line already digitalized. LV underground cables. Digitize first LV cable at 3 meters distance from parcel boundary. Additional LV cables will be digitized next to first LV cable towards street. Centerline up to first MV cable. If the number of LV cables are more and not having enough space available, between the first LV and first MV cable, 3 to 5 meter space, then we can utilize the spare area, between first LV and parcel to draw the additional cables. Refer the below depicted picture for the case of street width is more than 10 meters. Case 2. Street row width is less than 10 meters. MFI underground cables. If the street width is less than 10 meters, then we need to identify the center offset for the first MV cable, which is 0.25 meter below the street center line. I.e., if the street width is 8 meters, then first MV-UG cable should draw at 3.75 meter, refer below figure. Additional MV cables needs to be digitized by maintaining 0.25 offset from first MV cable towards the parcel boundary. LV underground cables. Digitize first LV cable at 3 meters distance from parcel boundary. Additional LV cables will be digitized next to first LV cable towards street. Centerline up to first MV cable. If the number of LV cables are more and not having enough space available, between the first LV and first MV cable, 3 to 5 meter space, then we can utilize the spare area, between first LV and parcel to draw the additional cables. Refer the below depicted picture for the case of street width is less than 10 meters. Case 3. Street row width is less than 6 meters. If the street width is 6 meter or less, draw the MV-UG cable first, below the street centerline, if any, and then digitize the LVU cables below the MVU cables towards parcel boundary. If there is no MVU cable in a particular location, then start the LVU cable next to street centerline. In most of these cases, MV lines are not available since these are all small streets, and not a major road since MV network will not available. Notes: when there is difference between as-built base map and latest base map, SEC recommended to follow the latest base map and draw the lines accordingly. Crossing of UG cables are allowed when the connection bends are, as per the internals of mini pillar and LVDB. Any new cable found from the latest as-built will be drawn down to the existing cable. These new cables are allowed to cross the existing cables. Underground joints. Underground joints for both MV and LV networks are captures as per the SEC. Inputs, as built, provided only, and there will not be any additional joints placed. Estimated path digitalization. We observed there are many locations SEC provided inputs are not sufficient to complete the underground network, and all the connectivity details are not available in the provided as-built hard copy maps. In these cases, we will draw the underground network lines with estimated path by referring to the source of supply numbers written in the LVDB areas, mini pillar, meter boxes. In many of the cases, SEC provided as-built not proving 100% connection details for matters to mini pillars, substations. Therefore, to achieve the maximum possible fully connected distribution network, we need to capture some of the underground cables by using estimated path. In these cases, we identify an identical appropriate route for the cable by considering the shortest route and the availability of circuit connection details in the LVDB, mini pillar boxes, and in meter boxes as per surveyed photographs. First, complete network having SOS full details and follow the below order to complete the estimated path network. SS, LVDB, CCT, MPP, MPPT, SS, LVDB.CCT, MP, SS, LVDB, CAT, SS, no SOS. Use the cable risers when there is a clear evidence that particular service cable is connected to that particular SS. Make sure all the lines captured as estimated path should have data source as estimated path and should have the same estimated path in comment as well. Here are some examples shorted down to describe the procedures of estimated path. Case 1 SS, LVDB CKT, MP, MPCKT. In the meter box, when we have the full SOS details as SS, LVDB, CKT, MP, MPCKT, we can clearly identify the source from which circuit of that particular mini pillar connected with this EDSP, and we need to use the appropriate route to connect this MP circuit. These cases are very much straightforward and to be completed with survey photos evidences that there is available free circuit must be connected with cable in the mini pillar with cable connected. Case 2 SS, LVDB CKT, MP. When we have SOS detail as SS, LVDB, CKT, MP, we can only identify from which mini pillar this EDSP is connected. Therefore, we can use any of the free circuit must be connected with cable in the mini pillar to connect the meters as there is no specific circuit mentioned, but we should be using only the used circuits as per survey photo, and we need to use the appropriate route to connect this MP circuit as depicted below. Underground service connection from mini pillar to meter, since the meter box and have the same mini pillar number, but there is no route available from as built, so it is connected from nearest mini pillar with the same number as mentioned in the SALD meter box. Case 3SS, LVDB CKT. When we have SOS detail as SS, LVDB CKT, we cannot identify from which mini pillar this EDSP is connected. Therefore, we can use the specific circuit from LVDB to connect the meters as per the UG network connections available nearest to the EDSP. Make sure that we should be using only the used circuits. Must be connected with cable as per survey photo. Case 4 SS. When we have only the SS as SOS, then we need to connect the next available mini pillar or the cable riser as per the SS, low voltage circuits running nearest. Below depicted picture shows the underground distribution connection from PMT to mini pillar, which is from as built, but the meters doesn't have any route from as built, so it is connected from nearest mini pillar. In addition, the meter box, source of supply only having substation number. Below depicted picture shows the underground service connection from cable riser to meter, but the meters doesn't have any route from as built, so it is connected from nearest cable riser, and the source of supply doesn't have substation number. Case 5, no SOS. When we do not have any SOS details in the meter box, then we need to look for the next available mini pilar. And is there any free circuit in it for connecting this meter box? As second choice, when we do not find any mini pillar nearest with free circuit as per survey photos, then look for the free cable risers available in the nearest poles to connect this meter box. As third choice, check for any nearest PMT has free LVDB circuit connection, which can be considered to connect this meter box. As last choice, we can check the nearest other type of SS, such unit SS, package SS, room SS, to make it use of their free circuit available with survey photograph. Evidence. We have to make sure the network nominal voltages MV, LV are appropriate. When we work with estimated path, none of the estimated paths should be created without proper support of survey photo providing the confirmation of a cable going from LVDB mini pillar or can be connected to the nearest meter box. In the same MV network, estimated path also can be created based on the SLD support and the survey photo evidences. In MV, we need concentrate on the switchgear and RMU evidences to connect each other with other supporting evidence from MV cable risers as well. In the below depicted picture, underground MV connection from substation to pole, MV cable riser, but the substation doesn't have any route from as built, so it is connected from nearest MV cable riser.